please welcome with an outstanding round of applause, Alistair Cockburn.
Guten Tag, Freunde. Alle Leute von der Schweiz, ich rede eher Schweizerdeutsch als Hochdeutsch. Haben wir Leute von der Schweiz her? Ja, Schweizer. Kommen wir. And everybody from Bavaria and Western Austria, all the dialects are the same, similar, so we do fine. I do very well with that. That's excellent. And so Hochdeutsch für mich ein bisschen schwierig, and also I haven't spoken it for like 15 or 20 years, so there's that. The most important thing I want you to learn from today is that the letters CK can sometimes be silent, as in words such as Cockburn. Maybe you missed that day in school. I don't know. But also I put Juan Manuel Garrido de Paz's name on here because he started chasing me around 2017, 2019, asking me difficult questions and refusing to go away. And his questions got better and better. And so finally we co-authored the book together. And there was no way I could write that book without him because he was Mr. Details guy. Everything about Java, UML, he knew everything. He knew these things were components before I knew these things were components. The guy was spot on it. He died 1 month before the book came out, if you can imagine that. Poor guy. But we did a book launch in Sevilla with his friends and everything, and it was fantastic. So I dedicate always the book and sometimes the talk also to Juan. All the details about Java and UML are very much due to Juan. Now, this is supposed to be a room full of programmers, and programmers, they want to program. I don't want you looking at your email or Facebook. I want you to program. Your challenge is to program the hexagonal architecture in the next 45 minutes before I get done, right? So get out your things. If I had an hour, we would have time to bring people up and look at the code. 45 minutes, I don't have the time, but maybe we go out afterwards, get a table and we can sit and look at how you did with your code. So programmers, get your stuff out, start coding. You could choose your own app. I always do tax things because it's very, you can scale it any way you want to. But maybe something more interesting is have an app that does bios of German poets or, something like that, something different, or choose your own app. But you must please use a TDD or at least have tests and show the tests. It's okay to have just one user service. The small is fine. We're looking at the structure that you get. You need at least one driven actor or secondary actors, they call it there. The structure is what we're after. Just make it easy to read, make it very simple. And strangely enough, it turns out that the folder structure where you put things is critically important, and we'll get to that. Although it's not strictly part of the pattern, it turns out to be where people make the worst mistakes. So pay attention to that and get ready to show your code at the end of the talk. Okay, that's the challenge. Do I have anybody? And it's best if you do this in pairs, by the way, because one person, you can get lost and make mistakes. Two people, you fix each other, and you also bother all the people around you because you're talking to each other while they're trying to hear the talk. Do we have any takers for anybody who's going to take this on? You guys from Innovate last night, you're like on deck here. Like I talked to these guys till midnight, told them I was going to do this. Yeah, get your laptops out, guys. You on it? See? Okay, good. Off we go. What's the point? The point is create your application to work without either UI or a database so that you can run the automated regression tests against it. You can work when the database becomes unavailable. You can upgrade a new technology. You can link applications together, and you can protect your code from leakage between the business and the I/O. That's a lot of benefits that you want to get from that, and I'm going to show you exactly how to do that. And what you'll find is when I start talking about how to do it, words beget more words, beget questions, beget more words, beget more questions. And the moment we go into diagramming, you will never stop diagramming because everybody's got a comment about a diagram. So I start off by just showing you the code, right? Copy this code. What is that, about 20 lines of code? When people say it's too complicated, I go, excuse me? I added about 10 lines of code to your code base, and I gift you all the benefits. So there's the code, and we'll walk through it. Just briefly, I'll just walk through it briefly, but we'll stare at it. And I'm very proud because I've got the entire hexagonal architecture on one slide in Java, right? That's pretty amazing. So we've got the app in the middle. It's the tax calculator. And the port, I always call them for doing something. So we know what the intention of that conversation is going to be. If there's going to be multiple, service requests, we're bundling it with the name. So it's for calculating taxes, and we have one service called get the tax on a certain amount. And so we've got main or whatever. And we're going to put a mock tax repository over there. And so the thing on the right-hand side is for getting tax rates, and it'll get a tax rate given an amount from the tax repository. If you read the code from right to left, right, I just have a mock there. And it's a class fixed tax rate repository. It's got a double tax rate, and it returns a constant 15%. Okay? Now, the thing that's the hexagonal architecture part of those two interface definitions, and the thing that's weird that most people don't get is both of them are inside your app. A lot of times people will put, especially the right-hand side, they'll put it outside the app. But that interface belongs to the app. That's actually the key part, the surprising part of the whole pattern. And so you've got on the left side, you've got a setter, the dependency injection thing here, and it gets the tax rate repository to use, sticks it in an instance variable, and now you can do anything you want. You can switch it. And then if you look at the main down at the bottom, the first two lines are what we call the configurator. Something has to do the wiring diagram, right? This is a wiring diagram kind of a thing. So it says, hook up the adapters and things like this. And then finally you use it, okay? That's the whole code. And by the way, I encourage you to put on your little recorder. I've been going to the talks here, and I just put on my memo because I can't keep up with all the words. I'm going to talk fast. So take pictures. The slides are on my website. I've got a QR code at the end. But if you want to record it so you can, argue over later, please do all of that, right? So that's where we're headed, and everything else from here is a lot of words talking about it, right? So here are the benefits of this thing. You get to set the app's driven actors at initialization or change them while it's running, or if you're doing a long-running application, let's say Netflix wrote a case study, technology shift, and you're going to have to shift. Maybe it was a file, then it's a database, then it's an internet service, then it's a. So over a period of years, while the thing's running, you're going to want to be able to swap those secondary actors or driven actors. You get to replace production connections with test harnesses and back again without changing source code. So people go, it's not a problem. I just change one line and rebuild it. And I go, why would you do that? You don't have to. You got that variable, just pass it in, and you don't have to do it. You get to avoid having to change the source code and rebuild every time you make these shifts. And here's the part that different people attach to different benefits. The one that I happen to attach to is you can prevent leaks of business logic into the UI or data services, and vice versa, leaks of the UI or data service into the business logic, because you have tests around this thing. And it is literally the only technique I know that will guarantee that you don't get the leakage. If you don't have the tests, you will have leakage. And I don't care what your bounded context picture says, the leakage will happen. So this is the way you stop it. Now, there are costs. I like truth in advertising, and I don't think it's a big one, but I made the whole list here. You have to have an instance variable for every driven actor, or you have to have a service that gets it for you every time, and I'll show you that. You have to have a constructor parameter for each driven actor, or a setter function, or a call to the configurator to get it. And you have to design and add a configurator, which is not part of the pattern, but you'll need it. Okay, so for like Ruby, Python, non-type check languages, you're done. If you're working in a type check language, now you have to have the required interfaces and the folder structure for the port declaration. So, when people say it's complicated, it's typically the folder structure that hurts them. This is a little bit of extra work. You saw the number of lines of code. It's like 5-6 lines of code. Not a big deal. Why did I come up with this? Okay, so I'm an application programmer. I don't do infrastructure stuff, but my infrastructure guys screwed me over a couple of times, and I hurt. And the first one, we were doing a network tracing system. I was using Smalltalk. We had Model View Controller, doing everything on the screen. I had a C programmer. And our first users were IBM, and they had a network. They weren't going to draw it. They had like 150 nodes and 10,000 things in a trace. And I said to my guy, okay, just take the input from the file instead of from the screen. And he looked at me like I had two heads, like, I can't do that. Now I have model view controller. I go, why not? You just switch this thing, right? You have this API, you just switch it. He couldn't. He had to rewrite his code. The next time, mid-90s, Smalltalk project again, same thing, tied to the GUI, and then they said, hey, we want to run these services from batch instead of interactive, broke all the architecture, and then the SQ, there was an object relational mapper they were building. They decided to redesign it, and I said, that's okay, just give me what's called a loop back, right? And so we can write our tests as we're writing the app, and you could be decoupled. And they looked at me like I had two heads and said, we can't do that. And they shut down the project for 6 weeks. And I'm going, guys, I know I'm entitled to do this. Why can't you give it to me? And then I have a friend called Mo, and he had a weather system, and you can look at all the inputs and outputs. And over time, it was, pagers and literally voice telephone, answering machine, and then it was RSS and all the different things. And he had everything coupled, and he was having to maintain combinations and permutations of these things. And I go, I don't understand why you're suffering. Just put an API around everything and you could swap them in real time. And he looked at me like I had two heads. And that was like around 1999, 2000. So I said, okay, this is a real thing. And I got to figure out how to do it, because I'm not an infrastructure guy, but if I demand it and they don't give it to me, I have to show them how to do it. So finally around 2003, 4 time frame, I was on a project and we wrote some code. When I had the code, right? And by the way, you're going to ask, why is it a hexagon? Because from 1994, when I first started drawing this, till 2004, for 10 years, I didn't know what the facets meant. I didn't want a square, because a rectangle, everything's left to right, user database, and you fall into the trap of these layers things. I didn't want that. I wanted radially symmetric. There's inside, there's outside, and I don't care. So you can't do a square, can't do a triangle, can't do a pentagon, and it's a hexagon. So I'm drawing this hexagon for about 10 years. Finally, I read a pattern called pedestal, and I'm working with that thing, and I go, this has to be done before. And then I reread adapter, and I go, oh, these facets, those are ports. Like on a stereo system or a serial port, parallel port, where you plug things in. Oh, this thing is called ports and adapters, but the word hexagon was already out there, and it's a cool name, One of the 3 worst names in all of the pattern literature. Anti-corruption layer is the second worst, and Buffalo Mountain is the worst, if you want to know the 3. But I'm in the top 3, anyway, for worst pattern names. But it's good marketing. But the real name is ports and adapters, and every facet is a port, right? And the things you stick on and the adapters are outside. People have trouble with that, and they go, oh, are the adapters inside or outside? Adapters are outside. Everybody, if that's all you learn, the adapters are outside. Okay? Got it? TLDR, adapters are outside. So now from here on, let's go into some kind of metaphors and things. And the way to think about this is, I used to be a hardware designer. You have a chip catalog and they give you a chip. Now the thing is, you don't get any say-so about what the chip pins mean, the voltage levels, you don't get to do anything. If you have 2 chips that don't meet, you have to put in the little glue chips, the gates and stuff to make them work. Those are guess what? Those are adapters. So if you imagine that your app is going to go in a catalog, it might not, but imagine it will. You're going to pretend it's going into a catalog, and the people who are going to use it will never get to touch the inside of it at all in any fashion, right? You have a component. Now, it might be you only ever use it once, but you think about it like a component, and you treat it like a chip, and you will never touch the inside. So guess what? You've got input pins and output pins, and it's very nice. UML has given these little lollipop things, and those are the input pins, and these little hook things, and those are the output pins. And I didn't write that up originally because they came up with UML 2.0 when I was still publishing this, so I didn't know about that till Juan Manuel Garrido de Paz taught me all this stuff. So we've got these input pins and output pins, and so the input pins, we call those driving ports. You could also call them, like from use cases, primary ports, but we call them driving ports. They drive the app. And the other things are driven ports. They are driven by the app. So we have driving and driven. And it turns out there's a kind of a left to right or top to bottom. Guess what? We get that anyway, left to right, top to bottom. And it's really useful. It's not enforced by the compilers. But we named the ports for the purpose, like for doing something. It's a really great convention. It'll simplify things, make things more readable. You're not obliged, but it's a good idea. Because each port can have multiple service things that it supports. So here now is that application. Generically speaking, you're going to have a test, development structure, and you're going to have a production structure. So there's the app. We don't have to do anything with it. You've got your test harness. It's a driving actor, and typically there are 3 kinds of input ports. This stuff for configuring it. Right? So if you're Netflix, you have a long-running app and you're going to be changing the technology, you'll actually have a port for configuring it and all the ways of configuring. You will have a port that's generically the user's using it, right? Using it. And usually there's an admin access thing to do things, so you'll have for adminning. And so those are typically 3 types of input ports that you'll encounter. And typically on the output part, you're going to have, like, say, pagers and emails. So there'll be stuff for notifying things. There'll be all the databases for getting, data. And you may have, like for a coffee machine, or as a friend who works at Rivian told me, an electric car looks a lot like a coffee machine. It's just a big computer with a bunch of driver motors that do things, right? So you've got controlling stuff. So you got 3 types of things on each side, and it turns out to be handy to have 6 sides because it's very common to have 4, 5, or 6 ports total. I'll show you how to make it work on a rectangle so you don't have to be tied to the hexagon. By the way, someone put on LinkedIn, Alistair's legacy will be people draw hexagons instead of rectangles. That's all I get for my whole life. And I've already seen it happen. People going, and they're not they're not hexagonal architectures. They're just like hexagons. And so you'll see architecture diagrams with hexagons everywhere these days. People do that with bounded contexts, and bounded contexts are dangerous. But I may not have time to talk about bounded contexts in this talk, but we did put several pages about that in the book. And now the point here is when you go to production, look at that. The app is the same. But you've got the startup, you got the GUI, you have the GUI, you have the devices, you just hook them up, right? The configurator wires it up, and away you go. So that's what that looks like. We'll see these diagrams here. So here's that Mose weather system that I showed earlier, and here's it with the ports, and you see the number of different driving actors that will drive the port that's called for collecting weather information. And then we had 3. We always have tests. There's always 2. You have your test and your production. Always 2. Guaranteed, and sometimes more. And there you see on the notifying subscribers, we've got the answering machines, the pagers, the emails, right, like this. So then he does his app, and he just, like, when new technology comes along, he hooks them up. So that's where we're headed. All right, how you guys doing on the code? Thumbs up. So we have no idea. Now here's the sequence. Here's the development sequence. Ron Jeffries, shout out to Ron Jeffries. I said it's very good because your test harness can be the second user of your app. And he said, no, the test harness is the first user of your app. And I said, oh, that's right. So the very first thing is we set up the test. You got the app, you got the ports, you set up your tests, you set up your mock database. So the first thing you implement is test app mock database. Okay, number 1, it's in light blue. The next 2, it kind of doesn't matter. I haven't seen that it matters. You can do now production driver to your mock database, or you can do tests to your production database, or swap your technology, put in a file system database, whatever you want, right? Number 2, number 3 kind of doesn't matter. And then in production, finally, you do production driver to your production database, right? But the point is you can flip back and forth at any time without touching your app. You just literally, send in the new thing. Okay, so here's the tax calculator. Let's just do that. I already kind of showed it to you, but let's kind of walk it through. So we got the tax calculator. We have a port that's called for calculating taxes, and we have another one for getting tax rates. Let's get at least 2 services on the left side there. We want the tax rate for a certain amount, and we want the tax on a certain amount. And I like taxes because we can make it stupid simple with just one service and a constant, or we can get really fancy in talking about taxes for EUs, where eventually someone has a direct line, to the tax service of Germany or something like that, and they get the real tax as opposed to having, database. So you can get arbitrarily complicated and fancy, but the drawing, stays the same. So I like this example, and so this is the one I walk through all the time. So now, are there any Ruby or Python programmers in here? 1 or 2, 5? 7. The Ruby people go, I don't understand why you need a whole hour on this. Like, what's the problem here, right? Because they don't have to declare all the ports. So this is the hexagonal architecture in Ruby. And there you see the constant 15%. There you see the constructor, initialize, take the parameter, stuff it away for future use. There you see they still have the configurator composition root, and then you see use it. So it's that many lines of code. So we've added like a grand total of, I don't know, like 5 lines of code to your Ruby per driven actor, right? So you may have 5 driven actors. So, but that's, to me, not complicated. When people say it's too complicated, I don't know where they get this from. Now, having done Ruby, now we have to get into Java, and now it gets wild. We go into UML, stuff that you didn't ever want to know, that I didn't ever want to know, but it turns out it's a good thing to know, to follow along. So those of you who are UML, Java hacks, this is for you. So in UML, they have this little lollipop thing, and it means that B implements the interface. Now, under normal circumstances, B also defines it. But really, what that little bubble says is B provides certain services and A uses them, so B implements the interface. We haven't actually said who owns the definition of the interface, but that's what that little lollipop thingy means. So that's useful. That's normally put on the left side. You define a public API. That's kind of life as normal. The surprise is the thing on the right. And the thing on the right, that little hook, is an announcement that A owns the definition of the interface. And it will make calls out that interface. It defines the language it will use. And B's got to implement that protocol. So A owns the interface, B requires it, and then B implements it. Right? A requires it and B implements it, right? And that's very useful for decoupling a component from its receiver. That's the weird part. That's the weird part that throws people. So we're going to dig into that a little bit more. This stuff took me years. Oh my God, I spent like 6 months putting these diagrams out on Twitter. And Vaughn, who was there yesterday, is one of the people commenting back, and that's not right because this line's not here. And then Juan was helping me with the current UML, and it took months, but finally we got this drawing that I think is useful. So on the driving ports, notice it's pretty normal. We have the component, it's got the API, it defines a component, and we have this dashed line, so the driving actor uses that interface. And if you look at the package, sure enough, the interface is defined inside of the app, right? And then it implements it. Pretty normal stuff we're used to seeing. The weird one, again, is on the driven side, it's where you don't expect it. So there's the component, and it will define the interface. It will use the interface. But the interface is implemented by the thing outside. Right? So those of you who like UML and packages, or if you don't like it, tough. This can help you just see what's inside. That's a weird diagram, as far as I'm concerned. So take a picture of that or whatever. I'm going really fast, I know, because I've got 37 slides, and I don't know how long it's going to take me to get through them. So I'm just going as fast as I can. And so here now, when we go to implement that tax thing, I just have that part right here. Okay, so there's the tax calculator with the little hook sticking out. It defines the interface for getting taxes. It's going to ask for tax rate on an amount. That's defined inside. There you see it using it down at the bottom. It says public double tax on, and it says tax rate repository dot tax rate of the amount. So it defines what the language it's going to use, and then it uses that language. The first time I saw this, I realized that. I said, that's awfully egotistical of these app programmers. They go, I will announce to everybody what language I will use, and you must all implement it. I mean, it's really freaky, egotistical, but you're making a component, so you get to do that. And there you see then the tax rate repository says implements for getting tax rates, and then implements the double tax rate thing. That's just that line. So now we can put that back together, with the thing that I showed you at the beginning, and now you recognize it. So there's the implements for getting tax rates done by the mock. There's the interface for calculating taxes for the left, interfaces for getting tax rates. That's the hook thing for the driven actors, the driven port. And then you see the constructor stashes it away, and the wiring there thing. And notice the type of the calculator. It's not, this is a mistake I made in the first edition of the hexagonal book. Did anybody here buy the first edition, the original 1 year ago hexagonal book? Good, don't do that. So So the book launch was in Juan's hometown, Sevilla in Spain. And I go there, and I had to pay huge amounts of money to get it hurried, printed, shipped across the ocean, and get there. And I do this thing, book launch, all big thing. And we go out on the street. This young guy comes up to me and says, I have a question about, page 11, like I say here, just says copy this code. So I just copy this code, page 11 of the book. And he says, I'm not sure, why do you bother defining that interface up here? And I said, oh, it's because, shit. He found a bug in my code, with his first question. And what I had done was, instead of saying, for calculating taxes, my calculator, I had a calculator class. And I said, calculator, my calculator is obvious. If you do that, you don't need to define the interface. So the type of the app is actually the type of the port, right? So you do that. It actually took me about 3 pages to clean up that discussion in the next edition, the current edition of the book. When you get it, it's got a couple of pages about that. So that's the type. And then there's a big fight. Should you call it calculator? Should you call it for calculating taxes? And I've learned there's 2 schools of thought, and I don't arbitrate that stuff. So it's all in the book if you want to chase it down. Now, if you're going to go into the UML world and the C++ world, it turns out that we got tired of saying, well, either the test harness doesn't have an adapter. It actually fits the port interface. But other things will need an adapter, like if it comes in off the web. So sometimes you have an adapter, and sometimes you have another app that knows the interface and there's no adapter. So we got tired of writing that, so we just used the word interactor, and an interactor means either it's the adapter that does it or it's a driving actor, I don't care which, but if you have a driving actor that needs an adapter, that's okay also. So there's your UML for you guys, and it's the same thing on the other side. So if you're a UML hack, then or you're doing an inheritance hierarchy, or you're doing something, you can play with that one. Juan wanted a more complicated example. He kind of got carried away. But in Sevilla, they have parking has different colors of lines on the road for different parking rates. And so we had a Blue Zone app, and so we have two driving actors, the car driver and the parking inspector. And it turns out that you need a rate repository to know that, in this part of the city or something, it's this rate because of this color of line. Then you need the permit storage that you get, and then you need a payment system. So we have three driven actors, if you will, and it's all on his GitHub. You can go and read the code. And then he likes to put the port name on the inside of the hexagon, so it's very clear that the port belongs inside the hexagon. I like that. If you like that, that's fine. So this is for parking cars, for checking cars, for obtaining rates, for storing permits, and for paying, right? So you see those words, why we like to say for doing something. And I'm not going to show too much of the code because, it gets very complicated, but here's the drawing with the hexagon, the way I do it. So you've got tests and real users. So you've got the test in Cucumber, tests in TestNG, and you've got the web UI for the car driver, and he made a command line interface. For the parking inspector, he wanted to make sure he had all the technologies all mixed up. And you'll see on the driven side, there's always a test double of some flavor, then the file adapter, database adapter, wallet adapter, whatever going out to those things, right? So that's what a diagram looks like when you hook them all up. And the nice thing is, because of the semantics of that hook and that thing on the right-hand side, it means you could swap any of those. It could be any of those things. You just swap them around, right? How am I doing? Have I lost anybody yet? I'm told that when I'm in Germany, it's very important to lose the crowd within the first 15 minutes so they believe you're smart. I was told that actually. I went to a talk by Butler Lampson. Anybody remember that? In the mid 80s, and they were trying to figure out how to do global naming, right? What's IP address? That was the big topic. Butler Lampson came to the ETH in Zurich, and California school of explaining is everything is easy, everything's relaxed. Your grandmother should be able to understand this. And I was sitting next to a German guy. He said this would never work in Germany. A German professor must have something so complicated on the first slide that he proves to the audience that he knows things that they can't follow. And then after that, he can relax and talk down to them and dumb it down so they can understand it, right? So I come from the California school, and I try to make it simple. Here now we start to get into the folder structures, and you'll see you've got a thing called ports, and in there you've got driven ports and driving ports, right? And people tell me after the workshop, the biggest takeaway was the value literally of separating driven ports from driving ports and driven adapters from driving adapters. Because you might have a lot of port definitions, you will have a lot of adapter definitions, and it's really helpful to know when you go in there, you're looking at a driving adapter or a driven adapter. So that is actually the biggest takeaway anybody takes away. Not part of the pattern, purely advisory, but I have learned, if I go to anywhere, don't write any code till you set up the folder structure. That's where all the big errors happen. So, okay, do that. And there you see what he did, right on the driven port. Is the driven port for obtaining tax rates, and you could rate, find by name, and this and that and stuff. And in the adapters, there was a lot more code. I cut it off, but there you see public class stub rate provide implements for obtaining rates, right? So that's what the code looks like. And if you write code, you know what that looks like, and if you don't, you don't. So it's fine. So I just made these pictures, right? So generically, I'll come in and say there's a hexagonal project structure. You got the driven adapters and the driving outside the app, and then you've got the app, and then you've got the actual, the driven ports, the driving ports. If you're doing Java or one of those things, and you don't have those if you're doing Ruby, but the other parts stay, and then you got your tax calculator. Some people like to put the interface definitions in a third top level folder, so that those sit alone and everything else depends on those, and we don't have any kind of tight dependency. And anyway, there you see them, right? For paying, driven ports, driving ports. I'm assuming you can read the slide a little bit. That's the folders, and like I say, it's outside the pattern. Just as practical advice, do that. Right. My example, I was in a workshop, and I don't program Python, I'm a Ruby guy, and I thought I could understand Python, but these guys were putting up their stuff, and I couldn't follow it. I was going like, and there's certain things in Python that are a bit different from Ruby, and that's fine. And finally I just said, I don't understand it, but I know it can't look like that. It just can't look like that. And so they went away, and it turned out that their folder names were weird. They were not self-explanatory. I couldn't figure out what was going on. They went away for about 15 minutes. They came back with these kinds of folder names, and I go, oh, now I understand it. All the code's in the right place. The intention's right. Da-da-da. So that's why I chase people around on the folder structure. Now there's this configurator. The configurator is something you have to do, and maybe that's where this extra complexity is that people don't like. You can put the configurator on the driving side or on the driven side. But let's pretend like we're doing a tax thing. We've got our mock repo, but we're doing for different countries, right? So we have different databases with the German tax system and the French and the Italian and the what do I know. And maybe they're not yet connected to the German tax authority. They're all databases. And maybe you're going to have to look that up on the fly. I don't know. So let's take a look at the two kinds of configurators you're going to do. Standard one is dependency injection. So you've got your configuration root, whether it's main or the test case. And the first thing you do is you tell the tax kit, please use this tax rate repository. You have a constructor and you pass a parameter, and then it can choose one of those two. Right? That's pretty standard. Now, I don't like the word dependency in version, so I try to avoid it. So dependency injection is a good thing. But then another way of doing this is dependency lookup. And so now let's say we've got dynamic. So the input request is going to say which countries are in the different databases. Now it's not a fixed, you can't do that in the constructor. It's not fixed. It's on a per call basis. Now you have a rate repository broker. And every call will say, I want one from Germany, this one's from Germany, this one's from France. And so you have to go to the broker and find out which database to use, and then you call out to the correct database. Or in particular, if now you hook it up to the German tax authority to get the real answers back, you can do that, and so on. So that's a dependency lookup, and that's an example of dependency lookup. But because every port must have two driven actors, one of which is test, we now have a port called get tax rate repository for getting a repository. Well, if we have a port called for getting tax rate repository, we have to have two driven actors, one of which is your test, one of which is production. Now we have to set up which of those to use, and now we're back to dependency injection to set which tax rate repository broker to use. You see what I'm saying? So those of you who are doing that, that's what it looks like. And if you're not doing that, then avoid it, right? Because it's complicated. So why is it called ports and adapters? And the answer is, I wanted a radially symmetric thing that wasn't a rectangle to avoid the top to bottom, left to right. The symmetry I'm after is there's inside and outside. I'm only after one design decision from you guys. I don't care if you use big ball of mud, clean layers, Ivar Jakobsen stuff, onion, whatever you like is your business. All I want's that dang API. Give me API and give me tests. I'm done. I'm out of there. I'm happy. Right? When you go to implement it, now there's a difference between the driven side and the driving side, the left side, right, and the right side. The mistake that people make is normally when you just think of your app, you put the adapters inside. You treat those as inside the boundary. So the thing is you shrink the boundary right to the moment where it touches the technology, right? And then the adapters are outside. Your TLDR adapters are outside, right? And we can talk about bounded context. I don't know if I have time. I have a bone to pick with bounded context, but I don't know if I have time for that with this one. Now, the other big question we always get is, how does this compare with layers? This is another thing that took me not only about more than 6 months, but I gave the talk multiple times, and then like a month after the talk, I'd find a mistake in the way I drew. It is really hard to draw this sucker. So it'll get a little bit complicated, but there's your standard 3-layer. And we get the difficulties, like I said, we've got the invoice system, 2 coupled to the database. We have a problem, everybody goes, ouch. What I want you to notice is that the direction of execution follows the direction of dependency. The things at the bottom is the database, and then everything depends on that. And it's very nice and natural, but we're gonna do what they call dependency inversion. What we wanna do is to put the invoicing system or the app at the bottom of the stack. It depends on nothing. It's a component, right? It's just hanging out in space. It depends on nothing. So it's at the bottom. So you have the GUI and the database, both depending on that. And so the weird thing is now that when you go to the database, the direction of execution is the opposite of the direction of flow. That's a little counterintuitive. And that drawing's going to get worse in just a minute. Okay, but that's the thing that's counterintuitive. It's all the right-hand side stuff that's the counterintuitive. And this is where when people say, what's the relationship with layers? Oh my God, we spent so much time on this thing. But I think I got it now. So this drawing is pretty and it's simple, but it's not correct. The database is in the wrong place. We'll get to that in just a minute. So if we go now on the left-hand side and we look at it, we break it apart. So there's an invoice system. We have the domain and business logic, and we got this thing that requests the services, right, from the database. And the problem is that the code in that is coupled to the database API, and it's inside the app. And that's what we don't like. So the first thing we do is we take the domain, and we see that red little hook thingy. We put the interface definition on the inside where the business logic is, and we put the implementation of that down in the adapter, right? So that's step 1, have the domain code request services using only domain concepts. For you people who do SQL and you say, yeah, we do blah, blah, switch on SQL, you still know about SQL. You shouldn't know about SQL. SQL is not a domain concept. If you want to know where the movie tickets are, you ask about where the movie tickets are. You don't do an SQL thing, right? So you create a separate adapter. We're starting to split it out, a little bit of refactoring. And so there's that last picture. And the winning picture is the one on the right now. This is the correct drawing. Because the database is not going to be dependent on your invoices system because it's also a commercial product that you bought from a catalog, and you don't get to change any lines of code in that one either. So both the database and the invoicing system are peers at the bottom of the dependency stack. Neither is allowed to depend on the other. So now you put the adapter. The adapter now depends on both, and you see that red hook interface defined by the invoicing system, used by the adapter, and you see that arrow with the bubble with the lollipop, interface defined by the database, used by the database, and called by the adapter. So the direction of flow goes wiggly-wop, like that, right? So against the direction of dependency. So that's the correct drawing. If you want to know how layer architecture maps to hexagonal database, that's a horrible drawing, but I did it for you, so there you are. So there's, kind of at the end, create your app to work without either a UI or database, so you can run automated regression tests against the application, protect your code from leakage, work when the database is unavailable, upgrade your new technology, and link applications together. So you have two apps, and they have the same interface. They understand the same interface. You just plug them together. There's no adapter. Now, small footnote that I thought was a footnote and I put in the book, but turns out to be a big topic of conversation in this conference when you've got bounded contexts owned by different teams. So what happens is where you want to put this boundary may be the set of code that this team has discretionary authority to change, right? They can change the API, the implement, whatever they want to do. And there's another team, and maybe to start with, they agree on what their API is, but over time the API drifts, and they each have ownership of the code, right? So you could have two apps like that. So it could be you create a hexagonal boundary around the team control of code. Now, this is super duper important. I have never in 30 years really mandated that people write regression tests till I got to this moment. If you don't have tests, you can't stop the dirty code from drifting across your so-called bounded contexts. Programmers, they just put code somewhere. And then later it's too late to clean it up. And we see historically tons of cases of this. So I am hardcore. If you call this hexagonal app, ports and adapters, we know that it's a port because you've got regression tests against it. If you have regression tests, it's impossible to leak business logic out or I/O logic in. It's impossible because the tests will exactly test the services offered by the app. If you don't have the tests, it's impossible to protect your code from that happening. So suddenly I go, okay, you got to have the tests, otherwise I don't talk to you. So if you got the bounded contexts and you don't have tests, you actually have no protection on those bounded contexts. If you put those things like ports and you write tests, then maybe you can call them, like hexagonals, thingies or ports and adapter architecture. So we're at the end, and I'm really getting my timing right, and we may have time for a question. I want to show you some additional resources here. First of all, Juan Manuel Garrido de Paz really put a lot of effort into his website, lots of examples. He translated the articles into Spanish. Many people find his words speak to them better than my words do, so go into it. And then look at what he wrote on his webpage. Praise makes you weak. You know what it's like to work with a guy whose byline is praise makes you weak? Good job, Juan. Don't tell me that. And then I made hexagоnalarchitecture.org, and it literally is just a list of links to things, articles by him and Thomas Pirin, and occasionally I find some things, I just stick it in there. And Tom and Kathy Azel just showed me this time, they've got actually wooden and plastic things, tangible concepts, as you can see, .de. And so you can really do this, and you see they even have the hooks and stuff, so you can really feel like I've got this interface and I've got these actors and these ones are driving, and I love that their port is right on the boundary, right? The port doesn't contain any code, it's just an interface definition. So you got the hexagons in the middle. So they have that, and so visit them, talk to them, and they'll hook you up with that. And then in the books department, so there's the one, make sure you get the one that says updated first edition. That's got the fix to the code. You can get Amazon, you can get Kindle or paper. Go to my site, you get an EPUB. You also get all the use casey stuff. And I put on Ecwid a mug, so you can actually order a mug. I don't get any profit off of that, but I'm happy also to send you the stuff that I have on the mug. I don't care. Make mugs in Germany, have everybody drinking. And when the moment I published it, somebody on LinkedIn said, you're missing one thing on the mug. You should have a picture of lips up above there with a line that says, for drinking from. So go do that. There's the check on there, but there's QR code if you want the slides. And I just want to ask you guys over there, how far did you get? They were listening too much and not typing enough. All right, thank you, everybody.